Data structures, algorithms, binary search trees. So first things first, what is a binary tree? In a binary tree, every node has 0, 1 or 2 children. Children are referred to as left or right child. A full complete tree has everywhere 2 leaf nodes, and if the tree is a complete tree, every level except the last level is fully complete. We can see an example here in this picture right at the bottom of the presentation. Now, what is a binary search tree? A binary search tree can perform insertions, deletions, retrievals, everything in O logarithmic and time. The left child always has a smaller value than its parent. As you can see here, the 3 has a less value than the 5 and the 6 has a less value than the 7. The right child has always a larger value than its parent. As you can see here, the 7 has a larger value than the 5, and the 8 has a larger value than the 7 and the 5. Everything to the left of the root is less than the value of the root, and everything to the right of the root has a greater value to the root. So if we meet these terms, then we can perform a binary search. Now for the insertion. To insert the first empty what we do is that we insert to the first empty spot that we find. An example here is if we start with 25, you can imagine that our first node is the 25, so it becomes the root. Then we add the 20. 20 has a value less than the 25, so it goes to the left. Then we add the 15. 15 is less than the 25 and it's also less than the 20, so it goes right to the bottom of at the left side. And finally we add the 27. 27 has a greater value than the 25, and that's why it goes to the right side. And thus we have a binary tree, which by the way is not a complete binary tree, because as you can see we haven't completed every level of the tree. Now for the min and max, how can we find the minimum and the maximum value in a binary search tree? So we get the tree minimum just by following the left values down to the leaf. As you can see here, the 15 is the minimum value. And how do we get the maximum value? We do get it by following the edges to the right, down to the rightmost leaf. As you can see here, the rightmost leaf is the 27, and that's why this is our maximum value. So in other words, you can find instantly the minimum value by looking at the bottom left side of the binary tree, and the maximum value by looking at the right side of the tree. Now if we shuffle the values and we start with another root, let's say here 15 for example, then we will end up with a different tree. If our array is sorted, then we end up with a linked list, and you can also try to do it and write everything down to a paper. So that was it for today. At our next videos we will see how we can perform insertion, traversal. Traversal is how we can move through every node of a tree. Deletion, and how to get the minimum and the maximum value from a tree using, of course, Java implementations.